In the book, Being in It for the Species, the guides give us very specific descriptions of the various bodies in the Planet X system. In this program, we will examine them one by one, and then we'll see how the Planet X system moves through our own solar system. This will be important because a common question we hear is, why is it we do not see the Planet X system behind us each year as well as in front of us? To answer this question, we first need to look at the bodies, which comprise the Planet X system. At the core of the Planet X system is the Nemesis brown dwarf star. It is 56 times the size of Earth and has the mass of 171,000 Earths. The largest planet in the Planet X system is Nibiru, as it is known by the inhabitants of this system. It is 6 times the size of Earth, and its mass is also 6 times that of Earth. It has a moon we named Farada, in memory of astronomer Carlos Muñoz Farada. In size and mass, Farada is comparable to our own moon. The second largest planet in the Planet X system is Helion, as it is known by the inhabitants of the system. It is 3.5 times the size of Earth, but as a bright gaseous planet, its mass is only 2.5 times that of the Earth. It also has a moon we named Harrington in memory of the U.S. naval astronomer Robert Sutton Harrington. In size and mass, Harrington is comparable to our own moon. The smallest of the 3 planets is Arbota, as it is known by the inhabitants of the system. It is 2.5 times the size of Earth, and likewise its mass is also 2.5 times that of Earth. Arbota is in a very fast orbit around Nemesis, relative to Nibiru and Helion, and has no moon. Now that we have identified the major bodies in this system, let's take a polar, look-down view of all these objects together, beginning with the smaller sister sun to our own sun, the Nemesis dark star. Nemesis is what is known as a brown dwarf star, which means it is small and very dirty and cannot be seen in the visible light spectrum until it is well inside our own system. However, its approach has been viewed in the infrared range by our governments for decades. The nearest planet to Nemesis is Helion, a bright gaseous planet, and here is its moon, Harrington. Next out is Arbota, the lonely fast mover in the system. And in the outermost orbit around Nemesis is Nibiru, which according to the ancient Sumerians means the planet of crossing. And finally, furthest out from the Nemesis dark star is Nibiru's moon, Farada. To get an idea of how large the Planet X system is in relationship to our own system, let's overlay one upon the other. To do that, we begin with our own sun. Next comes Mercury, then Venus, our own lovely third rock from the Sun, Earth, then the mysterious red planet, Mars, and finally Jupiter. Because the Planet X system is so relatively small when compared to our own, these planets will suffice for now. So let's place the Planet X system into our own to get an idea of just how small it really is. When you consider that we left Saturn, Uranus, Neptune, and Pluto out of the picture, the Planet X system really does look puny in comparison. Nonetheless, the question we hear more often than not is, why are all of our observations of the Planet X system near the Sun? For many, the assumption is that we should see the Planet X system in front of us as well as behind us once each year. So let's take a closer look at this assumption, which is based more on expectations than fact. In most people's minds, planets move around the Sun much like trains on a railroad track. You know where they're going, just like freight trains traveling on fixed rails. However, the Planet X system moves through space more like an airplane, and unless you're a flyer or you've taken a few flying lessons, this can be difficult to grasp at first. This is because, as every flying student learns, airplanes have a longitudinal, lateral, and vertical axis. Hence the term flying by the seat of your pants, because an important part of becoming a pilot is the ability to feel the orientation of your aircraft with your tuchus. Lucky for us, there is a celestial comparison between trains and airplanes when we look at comets. To set a background for this comparison, let's use this illustration of our solar system as seen from deep space. That outer ball, which has a cutaway section in this illustration, is known as the Oort cloud, and it is made up of all the debris left over from the formation of our solar system. Occasionally, a comet flies in from deep space and passes through our solar system. Called rogue comets, these comets are fast movers, and if they keep their distance, they can avoid being captured by the gravity of our own sun, at which point they fly right out the other side of our solar system, back into the pitch-black darkness of deep space, never to be seen again. Ergo, these rogue comets are what you might call the celestial freight trains. They've got a single-minded focus as to where they're going, and they just plow straight through. However, the Planet X system does not orbit our sun like a predictable freight train. Rather, it orbits our sun much like an airplane, on 3 axes: longitudinal, lateral, and vertical. Consequently, its movements are far more complex. In fact, in being in it for this species, the guides tell us that it moves through the skies like nothing we've ever seen before. To help us put that in context, we need to see how the Planet X system orbits our own sun relative to our own view of the sun and the Planet X system. To do that, we must begin at the ecliptic. This blue line stretching across the screen represents the ecliptic, which in a manner of speaking could be referred to as the sun's equator, or more accurately as the plane of our solar system. Imagine this blue line representing the ecliptic begins at a point in the very center of the sun, and then stretches out in a concentric ring to the 12 constellations of the zodiac. Using the observation reports we've published in previous Yowza.com videos, let's now plot the movement of Nemesis, the brown dwarf at the core of the Planet X system, relative to our own sun and the ecliptic as seen from Earth. Here's where our estimate of Nemesis was in 2010, based on the observations of Nibiru from 2010 to 2013. And here we see where Nemesis was observed in May of 2013. We used these 2 reference points to create a rudimentary orbital path based on the fact that Nemesis is in a 3,600-year-long elliptical orbit around our sun. And here we see estimates of where Nemesis will be at the end of this year on the opposite side of the sun. This explains why we cannot see it at this time. However, Nemesis will come out from behind the sun as it reaches its point of perihelion, that point in its orbit where it comes closest to our own sun. So with this background in mind, we're ready to take on the question: why are we not seeing the Planet X system in front of us and behind us each year? With that, let's return to our deep space view of our solar system. Like an airplane that flies on 3 axes, the Planet X system essentially does the same. While it is bobbing up and down, so to speak, it is also orbiting around the sun as well, no differently than any of the other planets in our system. Again, remember that the guides have told us that the Planet X system moves through our skies like nothing else we've ever seen before. The bobbing up and down motion is straightforward, but in terms of moving sideways in orbit around the sun, we need to look at the number of days it takes for the Planet X system to orbit our sun, as it bobs up and down through our solar system. Let's begin with Earth, which we know takes 365 days to orbit the Sun. What the guides tell us is that even though the Planet X system is bobbing up and down, it also takes 380 days for this system to orbit around our Sun as well. Now we're ready to put it all together. To the left, we see a polar look-down view of Earth, Nemesis, and the Sun. To the right, we see a side view of our solar system from the ecliptic, with Earth on one side of the Sun and Nemesis on the other, which is why we cannot observe it at this time. Keeping that in mind, let's now change our point of view. To the left, we still have the look-down polar view, but to the right, we now have a frontal view as seen from Earth. Here we see Earth and Nemesis as they track around the Sun in 2010. In 2013, Earth is seen catching up because it has a shorter duration orbit around the Sun, and so Nemesis appears closer to the Sun. Here we see an approximation of where we presently are, with Nemesis being directly behind the Sun in 2014. And here we see Nemesis coming out from behind the Sun several months from now. And finally, here's where Earth will be relative to the Sun and Nemesis when Nemesis reaches its point of perihelion. To see the full range of motion, let's view a composite of all these points in space. Because Earth orbits the Sun every 365 days and Nemesis orbits the Sun every 380 days, Earth has slowly been gaining on Nemesis, and this is why the recent observations of Nemesis over the past few years have always placed it near the Sun from our point of view here on Earth. Nemesis is presently behind the Sun and unobservable at this time. But interestingly enough, we have current observations of its 3 planets, Helion, Arbota, and Nibiru, and we're going to show them to you in the next part of our program, Planet X Observations.